All right, split the first TIPERS in half for momentum. So we're now going to do 10 to 16. I taught a lot of stuff in the first set, by the way, if you didn't watch them. I did a little bit more than just explain why I got the answers. So if you're going to go through those, you might find some stuff interesting. Likewise here. So cards are plungers, so they have different masses. The velocity of the card, okay. So they got, coming in, they got certain momentum, and then afterwards they have a certain momentum. So, and we have enough information from here that for each one, the first thing I notice is we can find the change in momentum for each of them. All right, so let's do that. So for A, for example, change in momentum is going to be the final minus the initial, which means the final, which was 0, minus 10 times, that's 40 kilogram meters per second. So that's a change of negative 40. But they're just talking about magnitude, so 40 works. So I'll do it here. Magnitude of that change is just 40. All right, so you would run through and do the same thing for the others. B would have a final of negative, change the momentum for B. It'd have a final of negative 10. Minus an initial of 30, which is also change of 40 when it's all said and done. Change of momentum for C, its final was negative 20, minus its initial, which was 20, which is also negative 40. Change of momentum for D, its final was negative 30. No, it's a 5 kilogram cart now. Negative 15 minus the initial, which was 25. I don't know. Look at that. Carry on. Square root of 7, 19. That's negative 40. So they're all the same. That's why they're all the same. Same deal. Rank the magnitude of the change in the momentum. So we're going to find the before and after here. So we're not using the force times time way of finding change in momentum or impulse. We're actually finding the change. And it's always after minus before, right? Final minus initial. So this is going to be, this is before, this is after. So the final is 30. And the initial was negative 30. So that's, make sure I get that right. That's change is 0. I made a mistake. Yes, minus a negative 30. I knew that was a mistake. That's a common mistake. I would smack your hands if you made that mistake. So it's this minus the negative 30, which is plus, so that's 60. It's an important point. If something bounces, it's always a doubling of the, if it bounces and comes back the same speed, it's always a doubling of the momentum. In this case, positive 60. That's for A. For B, so let's go through and try not to make that mistake. Well, that's 0. That's boring. But we'll do it anyway. So final is 0 minus the initial, which was negative 20. So minus a negative 20, that's change of 20. C. The final is 1 times is a positive 10 minus the initial. The initial was negative 10. So when we minus a negative 10, it's really adding 10. So that's 20. And then D, the final is a positive 20 minus the initial, which is negative 20. And this one is in fact 0. No, it's not. It's 40. Boy, struggling with that today. So negative, yep, that's going to be 40. So, I wonder if I gave that a 0 though, because that might have been, because I don't think this is quite right then. Let's make sure I did that right. 20 minus the negative 20, yeah, that should be 40. So I'm going to alter my answer here. A is definitely the winner. B and C are together, but they're here. So I'm going to put B and C here, and I'm going to put D here. It was my first correction of in a very long time. I must have made the mistake again here and forgotten the extra negative and made that 0. That's what I did. But the only way it's going to be 0 is if it's going the same speed at the same direction, then there's no change. Well, it's not. It's going the same speed, but it's going the opposite direction than what it was. And that momentum is a vector. Direction makes a big difference. All right. This was an optional one, but there's no options. Only opportunities. All right. Carts with spring plungers run into fixed barriers. The carts are identical, but carrying different loads and so have different masses. The velocity of the cart just before and after the impact is given. Okay. So, let's take a look at this. They want to know the change in momentum. Ladies and gentlemen, I think it's easiest in this case, when you look at it from the cart's perspective, which way is the cart being pushed? While, from the time it starts hitting this barrier until it's done hitting the barrier. Okay, so it might hit and then just, stop. It might hit, plunge, and then come back. But while this thing is pushing the barrier, which way is the barrier pushing the cart? All right. This can only push it to the right. So the barrier can only push left. So the forces by the barrier in every one of these is left. So then the direction of the impulse has to be to the left, because the change in momentum is also, right, this is where it's handy to know that, called impulse, which is force times time. They may be in contact for a different amount of time, I don't know, but their direction, which comes from the force, is left for every one of these. If you hit that barrier, it can only push you left. It can't grab you and pull you right. It can't push you up or down. It can only push you it's a normal force. It's a normal force. It's perpendicular to its surface. Left. Change of momentum. The magnitude and the change of momentum of the cars. So final minus initial. So 0 minus 10m, because the cars all have the same mass. This one, change is going to be is negative 10m minus 10m. This negative comes from this. This is the minus that comes with change in. And this is a positive momentum here, but that negative comes from the equation. So remember, change in means your final minus your initial quantity. All right, so there's that minus that comes with it. All right, so this is final, negative 20m, minus your initial, which is negative 10m. And over here, I get a final that's positive 20m, minus an initial that is also positive 20m. Well, this makes sense. Same direction, same speed. There is no change in momentum. 20m minus 20m, 0. All right, this guy has a change in of 10. It's negative 10, but they just want magnitude. This one has a change of negative 20, so I'll put the negatives here, but remember they just want the magnitude. And then this is a change of, let's see, negative 20 plus 10, that's negative 10, so that's a change of negative 10. So I would go B, AD, and C would be last, because C has 0. All right. We'll give him permission to skip this one. So we're going to go to this one. A 2-kilogram object accelerates as a net external force is applied to it during a 5-second interval. That the force is applied, the object's velocity changes from this to this. The change in momentum of this object during these 5 seconds was 8 kilogram meters per second. How is it? How did they get? Okay. So the impulse applied to this object during these 5 seconds was that. Let's just find that change in momentum. I'm not sure whether, let's make sure that change in momentum number that this student just gave us is correct. My final momentum is here, and I'm going to call that negative 7 meters per second. And I'm going to call this positive 3 meters per second. So my change is my final, negative 7 times 2 kilograms is the mass of the object, so negative 14 kilogram meters per second, minus, so this is my final, minus my initial, which would be 6 kilogram meters per second. All right. So I get this minus, this is positive, this one's negative, so I get negative 20 kilogram meters per second worth of change. So the impulse applied to the object, all right, so at this point, even if they thought they correctly found the change in momentum, their argument should have ended there, because impulse is the change in momentum. There's nothing else you need to do. This is the impulse. Period. End of story. If they wanted the force, then I could say, all right, well, if my impulse is negative 20, and that's equal to the force applied over the amount of time, and they gave me this time, then I could divide by, I think, 5 seconds, and the force would be negative 4 newtons. But they don't ask me about the force. They just want, he says stuff about the impulse. Well, the impulse, this is wrong, but if he thought this was it, just leave it alone. Because the impulse is the change in momentum. The time wouldn't come into play until you wanted to calculate the force. All right, let's try this again. So a 2 kilogram object. So I would do the same thing here. In fact, that's exactly what I show here. You want to verify this? Let's see. Final minus initial. Final, I chose this to be negative 7, this to be positive 3. So I got the same thing. And then as student states, the change in velocity for this 2 kilo is 4 meters per second. See, the change in velocity is actually positive 3 to, negative 7 up to 3. That's going to be 7. That's going to be a change of 10. It actually went from 3 to negative 7, so negative 10. But that's a change in velocity. And you can see that if you factor out the 2's here, the masses, you get negative 7, negative 3, it's negative 10. That's your change in velocity. So that's where this person went wrong. All right. I believe that is it for the second half.